All right, so starting with the homework here from last night. Do you guys remember where all the weather takes place for question 1? Yeah, that's at the layer that is closest to the Earth's surface. Oh, did you see what I just did? What did I just do? I did do the tropopause. What is the tropopause? Yeah, it is. The tropopause is just the dotted line that is where the troposphere stops and the stratosphere starts. And do you see how they tricked you? Hey, Michaela, put that away. Do you see how they tricked, well, me, maybe not you guys, but they put it first? Hoping you did exactly what I did and only read the first couple of letters. So that's answer 3. So I did that on purpose just to show you not what not to do. Question 2, 104 is what in Celsius? Yeah, that's about 40. Which source provides the most energy for the atmospheric weather changes? Where does all the energy come from that controls the changes in the atmosphere? That is all from the sun, and it is radiation from the sun. So within the troposphere, how does heat transfer around the troposphere? Curious if you got this one right. Can I see a show of fingers just to see what you put? I'm not judging, I'm just curious. Okay, I see a few. The rest of you are not willing to participate. It is convection. Those of you who put radiation, that's actually where I thought most of you were going to go. That's how the energy gets here from the sun. But within the troposphere, that's where the warm air rises and then the cold air sinks. The warm air rises, it cools as it's rising, and then it starts to sink, just like the lava lamp. What happens I actually just answered this. So as air rises in the troposphere, what happens to its temperature? It decreases. Is that because it expands or compresses? Yeah. So if you guys remember how I compare that to hot, sweaty humans. If you're hot and sweaty, what will you do with the people around you? Yeah, you'll move away from them. You don't want to be close to people when you're hot and sweaty. So you move away from them. And then once everybody's separated, what happens to your hot, sweaty bodies? They cool down. So that's due to expansion. Which graph represents what the temperature as the amount of carbon dioxide increases? So we have do you guys remember what carbon dioxide is? Oh, yes, it is CO2. I mean, it's a greenhouse gas. So carbon dioxide is a greenhouse gas. What do greenhouse gases do to the Earth's temperature? They cause it to increase. So if we had a little bit of CO2, would we have a warm or cold temperature? Warm. No, I'm sorry. I just don't know what I just said there. If we had a little bit of CO2, what would the temperature be? Cold. That's what happens on Mars. Mars has no carbon dioxide. Well, actually, they have no atmosphere. So no atmosphere, no carbon dioxide. That's why it's cold on Mars. But Venus, on the other hand, their atmosphere is filled with carbon dioxide and other elements. But carbon dioxide, there's so much on Venus that it's so hot on Venus, we can't even go there. So Venus is so hot because one of the reasons Venus is so hot is because of all the carbon dioxide. So that would be answer 2. Sorry for taking so long to say that. And here's another one that I'm curious if you were able to figure this one out without too much explanation. So it's saying the diagram to the right shows the movement of air over a mountain. As the air moves down the leeward side, which is labeled on this side of the mountain, the air will. So let's talk about what happens to the air as we go up the mountain. It gets colder. When you go up a mountain, it gets colder. So what's going to happen when we go down the mountain? It's going to get warmer. Now, is it going to get warmer because it compresses or expands? Yes, when air compresses, when they huddle together, compress, putting them together, just like humans, if they were to compress and cuddle, you'd get warmer. I guess I forgot to ask you guys what you picked on that one first. All right, they love this type of question. And this was similar to one of the test questions last chapter, because it says the balloon is going through just the troposphere. So it's not going through the entire atmosphere. It's only going up to that first dotted line. What will happen to the temperature and the pressure as we go from the ground to the top of the troposphere? There, they both decrease. So decrease, that's answer 1. So when you convert this, hopefully you converted this one to 30.21. And then when you convert this one, that's 1021. What is this thing and what does it measure? First of all, do you guys know the name of it? This is a barometer. And yes, you do need to know what the weather instruments look like. Remember, we've done 5 different instruments: a thermometer, a barometer. I guess technically there's 6 because I forgot about sling psychrometer and hygrometer. Then the anemometer, which measures wind speed, and the wind vane, which measures wind direction. You will need to be able to look at any of those and know their name. I do believe those would all be multiple choice, though. I do like this. Well, this one doesn't have the names, but they would be multiple choice. They're not going to expect you to know how to spell anemometer or psychrometer or any of those things. So that would be multiple choice. You need to know what they look like and what each one of them does. So what's a barometer measure? Air pressure. Speaking of barometer, this one makes you think a little bit. So the barometer indicates the pressure of 30 inches of mercury at sea level, and at 3.5 miles above sea level, it indicates a pressure of 15 inches. What is the best conclusion? So first of all, 30 and 15, what do you notice about those numbers? 30 and 15. 15 is half of 30, so keep that in mind. Does that mean that the humidity affects the pressure? Does that have anything to do with the fact that when you go up, the pressure goes down? No. Temperature affects pressure. That is true. Temperature does affect pressure, but is that indicated in this reading? No. Total mass of the air, about 99% is within the first 3.5 miles, or 50%. 50, that's that half. So what it's saying is, as you go up, and you can see that here, that once you go up just a little ways, the pressure is practically 0 because most of the weight of the atmosphere is down closer to the Earth's surface. And what happens as you go higher in the, at sea level, the temperature of the atmosphere decreases, the pressure usually. So we're at sea level, we're not going up in the air. If the temperature is getting colder, what's happening to the pressure? That one is increasing. Remember, what does cold air do? Cold air sinks. Remember, and if it's sinking, it's pushing down, so the pressure will go up. Density and temperature. If we're cold, what's the density going to be? High. And if it's warm, the density will be lower. So that's answer 3. We have not talked about 15 at all. So let's see if you can figure it out. The air humidity and the temperature remain, if the air humidity increases and the temperature remains the same, the air pressure will. What's humidity? Amount of water in the air. If we increase the amount of water in the air, what do you think is going to happen to the pressure? So for those of you who don't see that right away, when you increase the amount of water in the air, what happens to the weight or the density of the air? If you add water to something, it's going to get heavier and more dense. So if it's getting heavier and more dense, It's gonna push down more, making the pressure even higher. Right off the reference table, a pressure of 0.2, where does that happen? So some people struggle with where the heck is 0.2. If you notice, it says 0 here and 100 or 1 there. So the first line is 0.25, 0.5, 0.75 up to 1. So 0.2 is just really a little bit before that first line. Go up and then go over, and in miles, was it miles? Nope, in kilometers. So let's redo that one. In kilometers, it's right between the 10 and the 20 kilometers. So the only answer that could be is answer 2. And what happens as air goes up? What happens with pressure? That decreases. Anybody need anything explained on any of those? Okay. Yesterday, I did not remember to tell your class about the quiz tomorrow. So there's going to be a quiz. Actually, let me step back a second. I discovered that I forgot to give you guys a quiz for the whole third quarter. I normally give a handful of quizzes. I'm not going to count this quiz on the third quarter because only having one would mean that that one quiz was worth the weight of all the quizzes I normally give. So this first quiz is going to go on to the fourth quarter's grade. I am going to try to start giving you quizzes almost once a week. And I know that sounds like punishment, but it's not. The quizzes will be between 10 and 15 questions. I won't give a quiz the same week as a test, so it'll only be one or the other. And what those quizzes are going to be is they're going to basically follow along the packet, almost word for word. Or not word for word, but in the correct order. What I mean is the first question on the quiz tomorrow will have something to do with temperature. Because I said it'll be 10 to 15 questions, so there might be 1 or 2 about temperature. Then there'll be something about pressure. When I say something about temperature and pressure, everything that's on here is fair game. I promise I won't ask the definition. So no, you don't need to know about the whole kinetic energy thing. But you need to know that it's measured with a thermometer, how to switch back and forth between Fahrenheit, Kelvin, and Celsius. You need to know what an isotherm is. Again, how to switch back and forth. Same here. You do need to know, again, the instrument. You need to know how to switch back and forth, how they're shown on a weather map. With winds, I'm going to tell you, more than likely, a question about these guys down here is going to be on the quiz. Do you remember how to figure out which way the wind is blowing? Okay, let's review that real quick. Do not turn to that page, only because I wanted to see if you can remember it without just copying it off of your packet. So how about this? If you recall, there is a sun and a moon, so daytime and nighttime. During the day, which one's hotter, the lake or the land? Land is hotter during the day. Why is the land hotter during the day? Good, I heard lots of right answers there. So remember the whole specific heat thing? So if it's down closer to the bottom, so basalt and granite, rocks heat up faster because they have a lower specific heat. Water heats up slower because it has a higher specific heat. So during the day, the land is warmer and the lake is colder. Now, going from some of the things we remember, if we have cold air over the lake, which way is the air going? What does cold air do? Cold air sinks. So if the air is sinking, do we have higher or lower pressure over the lake? If it's sinking, yes, it's sinking, so it's going down and pushing down on the lake. So we'll have higher pressure over the lake. Again, because it's warm air rises, and so you'll have less pressure over the lake. Which way do winds blow? From what pressure to what pressure? High to low. So in this case, during the day, the wind will blow towards the land. I'm not asking you to memorize which way the arrows are going on each one. I'm hoping you can work through it the way I just walked through it with you. So again, what do I mean? Let's go to nighttime. At night, ask yourself which one's hotter, the water or the land? The water's warmer. So the water's warmer because it takes it longer to cool down. The land cools down way faster. So now we talk about the warm over the water. Because it's warm, do we have high or low pressure? Low pressure. Over here, it's colder. So do we have high or low pressure over the cold? High. By the way, just to ask, make sure you understand this. Why is it high pressure over the land? Because it's cold. And what does cold air do? Sinks. And when something's sinking, it's pushing down. So it's, again, which way does the wind blow? From what pressure to what pressure? High to low. So you do need to be able to recreate which way the wind is blowing. Don't waste your time memorizing it. You memorize a few facts, high to low. And again, you can remember about farts. Farts go from high pressure to low pressure. You can just work through that concept that you've learned since you were little kids. Hot air balloons rise. So if they're rising, they're not pushing down. Rising is going to be low pressure. Cold air sinks, so that's going to be high pressure. So if you can just remember those few facts about weather, then you'll be able to work through almost everything you need to know for this quiz. So again, with wind, you also need to know the instruments. This is on your lab. I'm not sure if it's going to be on the quiz or not. Remember that on maps, when they're going to ask you where's the wind moving the strongest or where's it blowing the hardest? It's when those isobars are close together. So when the pressure is changing really fast. So also fair game on that quiz will be the high and low pressures that we did. Remember, if you remember the high, dry, cool, and clear, that you will have pretty much everything that you need to know for that page. Humidity and dew point, they're also fair game on the quiz. So knowing again the hygrometer and the sling psychrometer, knowing that relative humidity of 100% means that it's raining or snowing. Temperature and dew point, if they're equal, it's raining or snowing. Also finding the relative humidity using page 14 of your reference table. I'm sorry, 12 of your reference table. And then the last thing that's fair game, not what we did yesterday or what we're doing today, but the weather station. That's also going to be fair game. So it's not, I'm not trying to get you to get a bad grade. I never do that. Anytime I give you any form of assessment, especially before a test, it's just to let you know how you're doing. Quizzes are only worth 10% of your grade. And like I said, I'm going to hopefully have 5 to 8 of them on this quarter. So one quiz is not worth that much in your final grade. But what it is for you to see, like, oh, yeah, I got this. I got 100 on the quiz. I must have a good handle on this chapter. Or if you get a 30 on the quiz, you're going to be like, I either need help from Mrs. Ritz, or I need to work harder, or I should pay more attention, things like that. And by doing that, then hopefully you won't do horrible on the test that does count a lot. So I'm not doing this as a punishment, I swear. When we have the quiz tomorrow, like I said, it's 10 to 15 questions. It's not going to be the whole period. So we will continue on with what we're doing tomorrow. Any questions about anything? Quarter ends on Friday. So make sure if you, labs, that's the biggest thing. Or if you've been absent, make sure you get your work in. And then, of course, 41 more class days left. All right. Let's go to where we were working yesterday. It is page 36. All my classes kind of ended in slightly different spots yesterday. I'm hoping that we did the first line, the example, and then this set of paragraphs here. So we didn't do density of air though? Perfect. That's exactly what I was hoping you were going to say. That's page 36. So we talked forever yesterday about what condensation is and what are some examples of condensation. So just remember that condensation happens anytime warm air cools so cold that the air can't hold any more water. I think one thing we missed about that explanation is talking about dew point. Do you guys remember what the term dew point means? Okay, so when temperature and dew point are the same, water comes out of the air. It can be in the form of rain or dew or condensation. So anytime you get that condensation on a pop can or a water bottle, that's because the temperature has reached the dew point. So when I breathed on the window and created fog on the window, that's because the warm air cooled and hit the dew point and water droplets form. And by the way, that's how clouds form. So one thing before we start talking about clouds will be a quick reminder about the density of air. I think this year we really don't even need to put this in our notes. So if you are positive you have this concept, you do not need to write this next bullet here or 2 bullets. But if you just need a quick reminder, warm air rises because it's less dense. Cold air sinks because it's more dense, and that's called convection. Again, this is what's happening in the troposphere. The layer of the earth closest to, or the layer of the atmosphere closest to Earth. So if you are positive, you are comfortable with the idea that warm air rises because it's less dense, cold air sinks because it's more dense, you don't need to write that. So the sun is where we get our energy from. But if you guys remember from last chapter, the earth heats up. How it works is the sun hits the earth. The earth absorbs that energy, but then re-radiates it back out into space. So the hottest part of the atmosphere is going to be the layer, well, besides the thermosphere, so I mean in the troposphere, the hottest part of the troposphere is going to be down here on Earth's surface, where we're out there, where the sun is hitting the ground, and then the ground is sending that heat back out into space. If you were to go up in an airplane, the higher you go, the colder it's going to get in the troposphere. So that's really important to remember. So the hot air is here on the ground. What does that hot air do then? The hot air that's here on the ground, what does that do next? Warm air rises. So it's going to rise. What's going to happen as that warm air is rising through the atmosphere? It's going to get colder because as the warm air rises, it will cool. Because remember, it's spreading out, and those hot, sweaty molecules are going to spread out and they're going to cool down. Warm air is going to rise. As it's rising, it cools. Eventually, it's going to cool and hit the dew point. What happens when warm air rises and cools so far and hits the dew point? It rains, or at least water droplets form. And that's how clouds form. So here's some warm air that's rising. Warm air rises. As it rises, it cools. Cools so much that it hits its dew point and water droplets form. That is how clouds form. And there's a special vocab word for that concept that warm air rises and cools. There's a new vocab word for that, and that's called adiabatic cooling. It's literally my favorite earth science word because it's just fun to say. Adiabatic. No, nothing for you there. Well, I think it's fun. Adiabatic cooling just means as air rises, it cools. So in all of those, this is all that needs to go in that whole set of lines there for formation of clouds. And again, I tried to keep it as short as possible. It works through exactly what we just talked about. Warm air rises. As it rises, it cools. Cools so much that it hits its dew point. Water droplets form. There we have our clouds. Eventually those clouds will get so heavy it'll rain. When you are done writing, I'm gonna need you to grab your reference. And I need page 13. I know it's page 13. I don't know if you just noticed, I did just remember to post the homework. Your homework is gonna be page 28. That page is all about wind. It's very similar to what we were just, like how we did the homework for temperature and pressure. So on page 28, if you guys want to see it, just the questions on the bottom, don't worry about the top half. So just the questions on the bottom. There's 5 questions there. And then yes, we're skipping all the way to 37, which is talking about graphs. It's just asking you to fill in the blank. For example, as temperature increases, what happens to air pressure? Yeah, as temperature increases, warm air rises, so pressure will decrease. So that's the first one. Then you need to put that on the graph. And I do want an explanation, which I kind of just covered. Why does the pressure decrease? Because warm air rises. I'm not looking for a book just because warm air rises. So now you only have 2, 4, 5 more of those to go. In the meantime, though, we're going to switch over to page 38, which is the last thing we're going to do today. And we're going to talk about air masses. What do you think an air mass is? Okay, so you're talking about the how, like the weight, like mass and weight are the same. That's not quite how we're using the word mass. It's not wrong, but it's not quite how I'm using the word mass. Is there another way that the word mass can be used instead of just talking about the weight of something? Okay, how big? That's again still talking about the size of it. What I'm getting at is if I said like the masses. Do you know what that means? A large group. And that's what we're talking about here. An air mass is just, I refer to it as a chunk of air or a large chunk of air, just like a large group of people. So an air mass, where is it? Sorry. Air mass is a large region of the atmosphere with uniform temperature and pressure. So just so you know how I'm using the word uniform. So we're right at the top here of page 38. So the definition first goes on those top lines. It's a large region of the atmosphere with uniform temperature and humidity. When I'm using the word uniform here, just like when you're wearing a uniform, you all look the same. So the Regents will use the term uniform instead of saying the same. So basically, it's a large region of the atmosphere that has pretty much the same temperature and humidity. There are 2, 4, 5 air masses that the region is going to have you be responsible for at least understanding. But again, good news, most of this is in the reference table. So they use these on weather maps, just like isobars and isotherms. They use these abbreviations every single time, and they mean the same thing. So they have CP, CT, MP, MT, and CA. Can you guys find in your reference table on page 13 what those letters mean? Yep, so it's right there. We're on the bottom of page 13, right next to the weather symbols that we did for weather stations. So for example, that first one is continental polar. Just like a lot of things in weather, they are named for where they are coming from. So if you're getting a continental polar air mass, that means it formed over the continent in a polar area. What do you think the weather that's going to come from those means? We have continental polar. Which part of that are you confident you know? Polar, what do you think that means? Cold. Let's talk about what continental means. So remember, they're named for their temperature. So in our case, we already know the cold. The other part is the humidity. If air is coming from over the continent, what's its humidity going to be, you think? Dry or wet? Dry. The continents, for the most part, are dry. So the type of weather you can expect with the continental polar will be dry. The dry goes with the continental. The cold goes with the polar. So the next one, if you haven't already seen this on your reference table, the CT stands for continental tropical. So again, you work with just the words they give you. What does the continental tell you? Dry. And what do you think the tropical is telling you? So you're thinking tropical rainforest, right? That's where your head went. Don't think tropical rainforest. The second word is always describing the temperature. So our choices for temperature are going to be polar and tropical. Cold and tropical stands for warm. So I wish that wasn't tropical, because my head thinks tropical rainforest too, and that's wet. But tropical is just the opposite of polar. So polar is cold, tropical is warm. Now the next one, MP, stands for maritime polar. It is. Do you guys know what maritime means? Yeah, it's water. Like marines, maritime, marines. So that's, you get the water there. So the maritime is telling you it's what? Sorry, wet. And what's the polar telling you? Cold. Cold. So wet and cold. And then wet and warm. Maritime tropical. The maritime is wet. The tropical is warm. Yeah, and so then the next one is continental Arctic. Continental, you've got, what does that mean? Dry. Now Arctic. Polar and Arctic. Any difference to those in your head? Arctic is colder. So that's going to be dry and very cold. You could, yeah. As long as you know that's cold. So again, these are named for where they come from. So you now see this map. And these are the air masses where they're forming. So if an air mass form, let's do this one in the bottom left. The first letter is going to be the M or the C. Why does this one get an M? Because it's over the water. So this lower left one is going to get an M. And it'll be cold. Let's think about it. Where are we on this map?
Right there.
We're right here. Remember, we're easy to find because we're in the general area of the Lake Erie and Lake Ontario meeting. Look how much further south this first circle is. That's going to be warm. So what letter do we get for warm? T. This first one's going to be a maritime tropical, which means if this, and here's the part I want you to add, if this air mass, this MT, was to blow over to Buffalo, what kind of weather would it bring Buffalo?
It would be cold. Because it cools down.
No, it's going to be warm, but let's go in order. The M tells us wet. So I'd like you to add this. So you're gonna add that arrow. It's wet and warm. So it's air that formed over here in a wet, warm spot. It will, yes, eventually cool down, but it will bring with it that, right, a warm, wet rain. Well, rain is wet, but. How about this one, which I think is Mexico, I guess it technically could be Texas, I'm not sure. Okay, so we get this C because it's over the continent. And is it going to be warm or cold? Warm. If air formed over Texas, it's going to be warm. What letter is warm? P. And again, that's what I need you to understand is if this air now blows from Mexico to us in Buffalo, what air is it going to bring? Dry and warm. Dry and warm. How about the last one there that's in the Gulf of Mexico? MT. M because it's over the water. The maritime is water. The T because it is in a warm spot. Again, if that was to blow towards Buffalo, we get wet and warm air. All right, let's finish these off. We've got this one off the coast of Alaska. MP, perfect. And again, if that was to blow to Buffalo, what weather would we get? Wet and cold. Let's go to this one in the middle of Canada. CP, because it's over the continent and it's in a cold spot. So what weather does that bring? Dry and cold. All right, this one off the coast of Canada over here to the right. M, Y, M. It's on the water, and what letter? I couldn't hear you. P, because it's a cold one. So that again brings wet and cold air. And the very last one, way up there in Alaska, that's going to be the CA. Notice there is no MA, only CA. CA, the C tells us it's going to be dry, and what does the A tell us?
Very cold.
Very cold. All right, so guys, don't forget your homework. You have, again, page 28, back in the beginning of the packet, and 37, which is the page before we were just working on. Quiz tomorrow.